Testing. 1, 2. All right, we're working. Bonjour. Bonjour. Obviously is French for hello. Bonjour. Can't believe I've waited this long to say hello in French. Bonjour. I actually went to France in 2017. I got a little bit of free time when I was on a work trip to London. I know that sounds rough, doesn't it? I had 3 days of free time and I immediately headed to the French Alps. The problem with that, I don't speak French. That was interesting. But I found that a bonjour would really warm people up to you if you even tried. Maybe you've heard stuff about the French people. Some of it's true, some of it's not. One of the things that's true is they all speak English, they just don't want to. So if you try to speak French, they'll be nice to you. Anyway, bonjour. I left you off with this wonderful graphic showing the relationship of the different levels of immunity. And as I mentioned several times already, with a multi-layered defense system, where the first 2 layers are innate. The very first layer is the barrier defenses of the skin and the mucosal membranes. The second layer is the non-specific defenses of the phagocytic cells, chemicals, and physiological adaptations. And then the third response is if something does get through, we make a defense against that specific invader. So let's work on innate immunity a little more. Now, I can't help but, no, I'm not positive for COVID, not that I know of anyway. Although my daughter is, my youngest daughter. So if I suddenly disappear and you can't find me or you wonder where I went, my youngest daughter turned up positive for COVID on Father's Day, and that bothers me. I'm having to fight my way through it. She lives in College Station. I'll go down there and hang out with her because I know she's scared. But I can't. And if I can't stand it any longer and I actually go do that, if I disappear, that's where I went. So, anyways, back to work. I've hit a lot of this already, so I can go through some of these slides pretty quickly. The structures of the innate immunity prevent entry. That would be the first line of defense, the skin and mucosal membranes, and what I just mentioned, the second line of defense, the phagocytic cells, our friend the natural killer cells, chemicals, and physiological processes. I certainly hope you remember at least this from AMP1. Seriously, we have the epidermis, the top layer of the skin. We have the dermal layer of the skin underneath it. Epi means, of course, above or on top of. Don't forget your words. Don't forget that word list. Don't forget those flashcards you made. Don't make me put some of those things on the third test and on the final. Just learn them because it's important. It's important what things you need to know. So epi means above or on top of, epidermis, above or on top of the dermis, the next layer of the skin, not typically considered part of the skin, but intimately associated with the skin, or the cutaneous region, as the skin is called, the hypodermis, or subcutaneous. So the physical barrier of the skin is good because very few things are able to get through there. And not only that, but it's an inhospitable place. I know, your skin is nice and it's soft and it's pretty and you look good in it. I'm just saying for something that wants to try and penetrate it, it's inhospitable. As part of our natural sweat, we release antimicrobial substances onto the skin. Immunoglobulin. So globulin is a protein, immuno, a protein functions, lysozyme, enzymes that lyse, that break down other substances. Sebum from the sebaceous gland, defensins, those are also defensive proteins. All, if something, now imagine that. Imagine this. I know I keep asking you to use your imagination. Have an imagination. Close your eyes, take a deep breath, and imagine a pathogen that's parachuting onto your skin. As it lands on your skin, it finds an inhospitable place, maybe like molten lava. It's just not good for a place. It's good for us, but it's not good for a place for them to land. And on top of that, we have a normal flora. A normal flora. Flora is a term that's a little bit antiquated, but we keep it. Refers to bacteria. When bacteria would grow in petri dishes, and when they were first studying it, they didn't realize that it was a completely different life form. It looked like plant growth. And so flora refers to plants, fauna refers to animal. So flora in the vernacular is also used to describe not just plants, but also bacteria and fungi. So we have, no matter how many times you wash your skin, if you've had microbiology, or when you do have microbiology, you'll do this thing where you wash your hands several times and take samples of the your skin, and no matter how many times you wash your skin, you can't get rid of the bacteria that live there. But that's good. They're our friends. They're a bacteria of the genus Pseudomonas, and we are adapted to live with them. They are adapted to live with us. They feed on dead skin cells, which is fine because we don't need them anymore. They're going to come off anyway. And so we're adapted to them. They're adapted to us. They don't eat our skin cells any faster than we make them. And so when this bad bacteria parachutes into this very inhospitable chemical environment, what it finds is the local villagers that are not happy that it's there. And so here's this bad parasite, infectious agent that lands on our skin, and it finds a chemically unfavorable environment and a biologically unfavorable environment. Our good bacteria are adapted to live on our skin. That's where they flourish, where the others are just trying to, get by. So hopefully, using your imagination, that you were able to visualize that. The mucosal membranes. Mucin is a protein that, when you hydrate it, water, forms mucus, which is slimy and slippery. And also, we have our own harmless bacteria, harmless to us, lining our mucosal membranes, that also outcompete more virulent types. And so our barrier defenses are chemically and biologically an unfavorable place for pathogens. And they work. They work great. They work really, really great. They work greater than. I am sorry. You know who I'm imitating. They work great. They work really, really great. They're the best, and they really are. Actually, humans have the best immune system of all the entire animal kingdom, and so we're pretty lucky there. And so it really is the best. And however, if the barrier is compromised, if we get a cut, or if something figures out a way to sneak through, then, well, we might have to call out the cavalry and bring in the innate immunities activated, the phagocytic cells and whatnot, and possibly even the adaptive immunity. The neutrophils and macrophages. I'm very enamored with these. Neutrophils and macrophages are equal opportunity phagocytic cells. Whatever it is that doesn't belong there, bam, they'll do it. They're the most prevalent leukocyte in the blood. They make up almost 2/3, certainly more than half of all the white blood cells, and they're the first ones on the scene. The neutrophils are our first responders. So shout out to the neutrophil. If I see a neutrophil in the drive-through behind me, I'm paying for its meal. And that won't happen because I don't eat drive-through food because it's not good for you. I cook my own stuff. I told you it was Taco Tuesday. I was going to make shrimp tacos, and I'm telling you what, slap me if I'm lying, but them tacos were so good. And yeah, the wife went to bed, so I figured I'd make this recording so I'd have it for you for tomorrow. The macrophages, the big eaters, they reside in tissues. Remember, they can be either fixed, staying in one place, or they can be on patrol. They might arrive a bit later, but they stay longer. And not only are the macrophages phagocytic against infectious agents like the neutrophil, but they're also the cleanup crew. We get injuries, dead cells, damaged tissues. The macrophages are the ones that will consume that stuff up. Even material that doesn't belong to us. You get a splinter, don't get it all the way out. The macrophages will come in and they'll eventually phagocytize the whole splinter. If you think back to AMP1, I know you love when I do that. You get a broken bone, and there's bone splinters. The macrophages come in and act as a cleanup crew. So there's your neutrophil. There's your monocyte. This is the one that is sort of hanging out, just doing whatever it's doing, and then when needed, can turn into a macrophage. It's hard to tell from the picture. These are different magnifications. So in order to compare the size of the cells, look at the different sizes of the red blood cells in the background. Red blood cells are closer to the size of the neutrophil. The monocyte itself is a much bigger cell. Here's the quick version of phagocytosis. And if you want to see a good phagocytosis video, search YouTube for amoeba feeds. Amoeba feeds. Now, amoeba is not a human cell, but they feed by phagocytosis, and that particular video shows the process real well. So here's whatever it is that needs to be engulfed. The phagocytic cell will extend what are called pseudopodia, false feet, around the infectious agent. How do they do that? They do that with the chemical signals. They realize that this is not supposed to be there, and so the chemicals from what's not supposed to be there are strong here and weaker over here. Eventually, it gets enveloped into what in the good old days was called the food vacuole. But, food vacuole, that makes sense. It's something that a cell ate. But now we're going to call it a phagosome, a body as a result of phagocytosis. I just love it when they change names. Just imagine this. As I sarcastically say this throughout the semester, imagine that you spend all this time learning all these terms and words, and then, 2-3 years from now, they decide, oh, we're just going to change those words. I think you would be a little bit upset too. Anyway, the phagosome gets combined with a lysosome, and that's from AMP1, so I'm not even going to mention what that does, but then that process, what the heck, I'm going to try and say that word. I don't think I've ever seen it before. Phagolysosome. Really? Anyway, the digestive enzymes in the lysosome break up whatever's in the food vacuole, and then the waste products are released by exocytosis. Sometimes the phagocytic cell will consume infectious agents faster than they can break them down, and then they end up dying, and that becomes pus. And I know some of you twisted people out there watch that YouTube channel lady, Dr. Papa Pimple or whatever. That's freaking disgusting. And anyway, God bless it, people like you are here, because I can't deal with that stuff. And if you're somebody who can watch Dr. Pimple Popper, we need you in healthcare. Basophils and mast cells, what do? Well, the basophils, they circulate in the blood, and they are like the mast cell, only they circulate with release the histamines when the issue arises, secrete the heparin so that the blood doesn't coagulate, and that the vasodilation happens in the neutrophils and can leave circulation by diapedesis. And was I'm not even going to discuss that word. We're just going to go that the basophils circulate in the blood as a signal molecule, containing the signal molecule is histamine, whereas the mast cells are fixed in the different tissues as surveillance, but they both can call out the agents of the immune system. Here's a mast cell, I guess, with its histamine molecules. Looks like, yep, some areolar connective tissue. So here's a basophil. I do believe we would actually find it inside the blood vessels, but we have it out here right now. The histamines cause vasodilation. Blood vessels get bigger, increases the permeability of the capillaries. And so here's an important, when I say that, and sometimes I say important, like, yeah, that's going to be on the test. And sometimes I say important because, yes, this is really key to how it all works. And I don't know how I would ask a test question about this, but I'll think about it. The increased capillary permeability, that means that more fluid is going to leave the capillaries. So remember back to my story about imagine yourself as a water molecule in the circulatory system. And what happens when you come across increased capillary permeability? Well, that increases the likelihood that you're going to get flushed into the interstitial fluid. And so now what happens? Well, there's a problem here. There's either an infection, there's an inflammation, there's something going on where we have to call out the agents of the immune system. So by increasing capillary permeability, there's going to be more fluid flushes out of the circulatory system. Where is that fluid going to go? Only so much of it is going to get reabsorbed. It's going to help wash the interstitial fluid and the usual suspects into the lymphatic system. And then what's going to happen? They're going to get dealt with at the lymph nodes. So there's that. I like to say very elegant. Natural killer cells with a beard, wearing sunglasses. They patrol the body, detecting unhealthy cells, immune surveillance. Exactly. So they're almost like the secret police of the body. And they go around looking at cells. Yeah, okay, you infected with the virus? You must die. Are you a cancerous cell? You must die. Speaking of which, speaking of cancer, still don't have an actual name for my stepbrother's cancer, but I did find out today that his round of chemotherapy did not work. So I got a stepbrother that's about to die from leukemia. I got a daughter that is COVID positive, and I'm talking about immunity. What an interesting situation to be in. They destroy unhealthy cells by releasing cytotoxic chemicals. These cytotoxic chemicals include perforins. A perforin it's very similar to complement, which I haven't discussed yet, but these are proteins that penetrate the unwanted cell and open a hole in the side and let its contents out, and initiates apoptosis. This is a term that's becoming more and more popular these days. Apoptosis means cellular death. They induce apoptosis. It's like the natural killer cell goes up to the unwanted cell and says, you must die. Kill yourself. And the cell goes, and dies. It's kind of like the natural killer cell is kind of like Darth Vader going up to another cell and saying, I find your lack of faith disturbing. You must die. Here's the perforins. So the natural killer cell, these proteins go in, open up the cell membrane of the unwanted cell and make it shrivel up and die. Interferons. Interferons, a group of antimicrobial proteins. So there's not just one, there's a lot of different kinds of them. It's a non-specific defense against viral spread. So what happens with interferons is they're released from a virus infected cell. It's like an emergency beacon that says, I have been taken over by enemy forces. Please raise your defenses. And so these interferons released by a virus infected cell tell their neighbors, hey, I'm infected. There are infectious agents around. Prepare yourself. Strengthen your defenses against the viruses. These interferons also call out other agents of the immune system, the macrophages and the natural killer cells. It's basically an infected cell saying, hey, kill me before I can spread the pathogen. Interferons are a huge area of research for anti-cancer and antiviral agents. It's just not real well developed quite yet. Complement. Let's try this again because I think this is fun. This is something I would do in class all the time. Let's go back to fine. All right, I guess we won't. Anyway, complement's very similar to the perforins, where there's a group of antimicrobial proteins that cause a hole in the side of a cell and make it deflate. Here's an interesting statement here: composed of at least 30 plasma proteins. So what does that statement tell us? Do you think that medical science knows how many proteins make up complement? Otherwise, no. Otherwise, the word at least wouldn't be there. It would be composed of 30 plasma proteins. Composed of at least 30 plasma proteins. Maybe we've identified 30, but there might be more. Like almost all blood proteins synthesized by the liver, and they circulate inactive. And a lot like the clotting factors, they don't get activated until they need to be, and then there's a cascade of events that amplifies the signal and causes the complement to attack the offending cell. Oh, that's a good one. Good place to call this one. So, where were we? Try to turn this thing off. So, I must say then, au revoir. Au revoir, of course, is goodbye in French. So, au revoir.